word problems, which is why I printed notes for you, so you're not trying to copy down the problem. We can focus on how to solve it. Let's start with some kind of going back to things that we have talked about before. If you look at a quadratic, how do you know if it has a maximum or minimum? Right. Look at the first number. If it's positive, it opens up and has a minimum. If it's negative, it opens down and has a maximum. So this one has a If I ask you what the value is, what am I asking you to find? The vertex. Okay. How do we find a vertex? So that would be the opposite of -2 over 2 times 3. So that is 1/3. Is that my answer? No, we need the y. So if you plug that in, let's see, you get two-thirds. So really what this means is your vertex is 1/3, 2/3. When I ask for the true maximum or minimum value, really all I need from that is the y, because that is the measure of the height. So this is a minimum value of 2/3. So we have to find the full vertex, but really for the minimum, all I need is the y portion. Questions there? I got my good Kleenexes stashed back in the corner. Okay. Moving on. Find two consecutive integers whose product is 56. Now you could probably just think about this long enough and figure it out, but if I gave you a weird product, you wouldn't be able to, so I want to talk about the process. I don't want you to just write down an answer. I want to think about how we could use our algebra to get the answer. Now back when we did word problems at the beginning of the year, I told you you always had to identify your variables. So pick a letter. Everybody likes x. I'm going to say x is the first number. If they are consecutive, how would I define the second number? If my number was 2, what would the next one be? Consecutive just means the next number. Yeah, x plus 1. Now if I'd said like consecutive even, then you'd have to do x plus 2. What if I'd said consecutive odd?
X plus 1. 3. I don't know.
Give me an odd number.
7.
1, 7. Okay, so if you're at 1, what's the next odd number?
3.
How much do you have to add?
2.
If you're at
an even number.
Yes, even if it's consecutive odd, you're still going to add 2. Okay. Then we had to write an equation. So I said their product. What does product mean? Multiply. Is means 56. Now is this like a question I would have put on your quiz yesterday? Yeah, we could solve this. Distribute, set it equal to 0. So I could subtract over my 56. Box method. What multiplies to negative 56 and adds to 1? Negative 7, positive 8. So if you set them equal to 0, you get x to be 7 and negative 8. Am I done?
No.
How do I want you to answer a word problem?
With a sentence.
With the sentence, okay. So the numbers are 7 and -8 consecutive numbers? No, really we have two possible solutions. If the first one is 7, the second one is 7 plus 1, which is 8. So the numbers could be 7 and 8, or I also got an x value of -8. If the first one is -8, -8 plus 1 is -7. So we have two possible combinations. +7 and +8, -7 and -8. Both are consecutive, both multiply to 56. Questions there?
Bless you.
Let's look at another one. Sure. Okay. Suppose x represents one of two positive numbers whose sum is 33. Okay, so this time I didn't say they were consecutive. I can't just do x and x plus 1. I'm just saying there are two numbers that add up to 33. Part A, represent the other number in terms of x. So let's just think in terms of something different for a second. Let's say I added up to 10, and the first number was 6. What would the next one be?
4.
How'd you get it?
10 minus 6.
Okay, so they add up to 33, and the first number is x, so the second one has to be
X is 33 minus,
33 minus x. The big one minus the small one. So the sum minus x. Or if you don't like that, think about it. If you called it y for a second, we're saying that x plus y has to equal 33. So if I solve for y, I subtract over my x. So the other number is 33 minus x. Okay. What are the restrictions on x? Okay, I said it had to be a positive number, right? So my restrictions, it has to be bigger than 0 and less than 33. Why does it have to be smaller than 33?
Because that's to add to 33.
Right. If I'm going to add two positive numbers, it has to be smaller than the sum. Okay. Find a function that represents the product of the two numbers. So function, I'm just going to write f of x. What does product mean? Multiply.
That's what I mean.
So the first number was x and the second one was 33 minus x, so it's just x times 33 minus x. If you wanted, you could go ahead and distribute that and make it 33x minus x squared. Doesn't matter. Okay. Let's say I want the maximum product, the biggest possible product I can get. How would I find my numbers? Okay, go back to this. What kind of equation do we have here? What kind of equation is that, guys? It's a quadratic. Okay, if you prefer, you could write it as -x squared plus 33x. Alright, it's a quadratic. It's a parabola. Is it opening up or down?
Down.
So It has a maximum. How do you find that maximum?
Negative here to it.
Yeah, I'm just asking for the vertex. Opposite of 2 over 2a. So negative 33 over 2 times negative 1. So I get negative 33 over negative 2, or 16.5. Am I done? No. I found the first number. I want the maximum product, so what do I need to do with that? Plug it back in. Okay, so this tells me the number. So if I plug that back in, and I get 272.25. Okay. Let's answer the questions. The questions were, what are the two numbers? So the numbers are my first x value was 16.5. If I want the other one, I have to plug it in 33 minus x. So 33 minus 16.5. 16.5. The maximum product is 272.25. So really, this was a long, drawn-out way of really asking you to find a vertex. And that's all we were doing here. Just trying to make you understand.
Can you just write if it's the same number, can you just write it once?
You could say both numbers are 16.5. That would be okay. All right. Is that okay? Let's go to this one. A piece of machinery makes rectangular sheets of metal such that the length is 3 times the width. What do you think I should do right here? Okay, I have a rectangle. Okay, the length is 3 times the width. Do I know what my width is? So if I call that x, what would my length be? Okay. Equal sized squares measuring 5 inches on the side can be cut from the corners so the resulting piece can be folded into a box. So they're saying you take a little rectangle, you come in, you cut out every corner, and pretend I can cut evenly without measuring here. So I cut the same size square out of every corner. So you have something like this. And then if you fold up those tabs, you get a box. Does that make sense? So take a rectangle, cut out the corners, fold it, and make a box. All right. So I am going to cut out these corners. And after I do so, we have a nice box. So I'm going to draw the box over here. there's my box. I'm not much of an artist, but that's
Yeah.
Yeah, this is not gonna be.
a box is about the extent of my artistic abilities. Okay, let's see if we can label the dimensions on this box. So this side was X, but I came in and I cut off the squares that were 5 inches. So I took off 5 inches on this side and 5 inches on this side. So how much have I removed altogether?
X 10 inches.
It was X, you take 5 off each end, so now it's X minus 10. This side was 3X, but you took 5 off each end, so now it is what's wrong?
Just look at my box right now.
It's fine, it's fine. I'm not grading our art here.
Our tears different.
Okay, last question, the dimensions on this. The height of the box. This right here. What would that be? What?
Wait, say that again.
Yeah. How tall of the box? The box is, the height is formed by the side you cut, which was 5, so the height of this is 5. Hmm? Yes.
This is geometry.
We can do this. Yes, ma'am.
So how did you do that?
The 5?
I mean, yeah, and the X minus 10.
Okay. So if you think about like the piece of paper I cut. So this, before I cut, this whole side was X. But then I took 5 off this end and 5 off this end. So I removed 10 total. So it's X minus 10. This one was 3X, you cut 5 off here and here, so now it's 3X minus 10. So I removed 10. When you fold it, the height of the box is just the width of that square that you cut out. So that's my height, which is 5. Okay. Let's go back to reading our problem. The volume must be 1,435 cubic inches. How do you find volume?
With an equation.
With an equation, yes. Do you guys know what the equation is?
It's like the volume of R pi or something like that, right?
You're thinking with a circle. With the box, it's just length times width times height.
Oh my
So, if I multiply these dimensions, I have 5 times x minus 10 times 3x minus 10 equals 1,435. Okay. I want to know the dimensions of the metal and the restrictions on X. We'll answer that part towards the end. If I want to solve this, we have a couple options. We're going to have to multiply this out regardless. The 5, I could distribute it, or what could you do on each side? Yeah, why don't we just divide by 5 and get rid of it? Okay, I'm going to go ahead and FOIL that out. So we get 3x squared minus 10x minus 30x plus 100. I'm going to subtract over my 287 because we want to set our quadratic equal to 0. Okay. What do you want to do now? We can try dividing by 3. Unfortunately, 40 does not divide evenly. Box method?
Or quadratic.
Yeah, we can do either one. Let's try the box. If we can't figure it out, then we can always go to quadratic. Okay, those multiply to negative 561.
It's a small number.
Yeah. I mean, it could be so much bigger. And it needs to add to negative 40. Find the numbers. It does work.
33 and 17.
What?
33 and 17.
They have to be the different signs though, because we need a negative. Everybody should be trying. You shouldn't just be looking at me. Everybody found it? Have you divided it by 11? Yeah. Negative 51 and positive 11. Okay. 3x squared and 51x, you can take out a 3x. 187 and 11, you can take out an 11. This way we would take out an x. 51 and 187. Let's see, what do they have in common? 17? Negative 17? Of course, if you struggle with the larger numbers, you could do the quadratic formula. If you set each of those equal to 0, subtract our 11, divide by 3, we get negative 11 thirds and positive 17. Okay, the question asked a few things. X represented the side of that original piece of metal. Are both of these answers possible? Can you go cut me a piece of metal that has a side length of negative 11 thirds? No. So that one's out. It asked me the dimensions of the original metal. Okay. So if you look at your picture, it was x and 3x. So if x is 17, 3 times 17 is 17 inches, 531 inches. I also asked you for the restrictions on x. We just decided that x couldn't be a negative number. Could it have been like 5? That seems fine here, but could you remove 5 inches from each side if it was only 5 to begin with? So it would have to be at least how big? 10. It's got to be bigger than 10 in order for us to be able to cut that off. So the restrictions on x would be x is greater than 10. Or you could think of that as 10 to infinity. Really just ask that question about the restrictions to make sure you're aware of what would be a reasonable answer and what would not. I couldn't say it was originally only 7 inches wide because then I could not cut 5 inches off each side. So it's got to be bigger than 10 for me to be able to do that. Okay. Questions there?
So where did we get that one?
The 51? I plugged the 17 in right here. Other questions? I want you guys to take a few minutes and set up the next problem. See how far you can get. It's very simple. So we're still starting with a rectangular piece of metal. Don't try to shortcut it. Take time, draw your pictures. The length is twice the width, so the sides are x and 2x. You know, one thing you get credit for on these word problems is defining your variables. If you don't draw me that picture, then you have to tell me in words, the length is 2x and the width is x. Somehow I have to know what x represents in your problem. Then we cut our squares from the corners to get our box. This time the squares are 10 centimeters on the side, so you cut out those. So this was x, but I removed 10 here and 10 here, so now it's x minus 20. This was 2x, but I removed 10 here and 10 here, so it's, okay, the height, you make your fold on the line where you cut your square, so how tall is it? Okay, the volume is 7,500. Volume is length times width times height. Okay. What do you want to do first to solve this?
Divide by 10.
Okay, so then we can multiply that out, so we get 2x squared minus 20x minus 40x plus 400. If I want to set that equal to 0, we'll have to subtract over our 750. What could I do before a box method on this? Divide by 2. So 350 divided by 2. Okay. Box method, we can do the shortcut now because it's a 1x. Multiply negative 175 and add to 30. So we get x equals 35 and x equals negative 5. Are both of those answers okay?
Negative 35 is not.
Not be negative 5.
Negative 5 is not. So then we have to answer the question. This time I asked you for the dimensions of the box, not the metal. So the box is, all right, if my x is 35, 35 minus 20 is 15. 2 times 35 minus 20. And the height was 10. So make sure your sentence answers the question that I asked. This one wanted dimensions of the box itself, length times width times height.
Okay, so you got the 20 because you cut out 2 times on the
Yes. Other questions?
Why do we have 30?
Because I asked about the box, so you have a length, a width, and a height. I think this is where I'm going to stop today. There is a Math Excel assignment. Now, we have not talked about everything. So this one is due on Tuesday because we will finish the section on Monday. It is like 14 questions. I think right now you could do you could probably do 1 through 7, just from some of them we maybe haven't talked about today, but we've talked about things in the past. You can definitely do $11. You could probably even do a few more than that. So you know how to do the majority of